We'll see another technique based on BFS and DFS today. We have already seen BFS example in other videos in this playlist. So that's BFS example is it's a row level traversal. So in the row level traversal in a tree example, you can see that's BFS example, and for the DFS we can say the recursion is DFS, because in a recursion we can go deeper and deeper. So that's a DFS. And in a breadth first search is it's a like row wise. So in a row wise traversal, that's the example of BFS. We can see many examples based on this BFS and DFS also. Today we'll see one example based on BFS. Let's try to understand the problem from leetcode, and then we'll see the solution. So this is a problem for today. It's a number of islands. So let's understand this number of islands problem. So here there is a two-dimensional array, and there is a grid, and we have to find out the number of islands present here. So 0 is water and 1 is island. So if you see this example, 1 is island, and we have to count how many islands are here. So if you see 1, and there's a 1 connected here till here, it's a connected, so we have to check all this connected 1. So till here we can say there's a 1 island. So this is all connected, so this is a 1 island. And yeah, see till here this 1 is also connected. So from here 1 1 1 and 1, this 1 is connected. So it's all together 1 island. And the 0 0 is a water. So in this grid there is only 1 island. If you see this example, you can see 1 1 1. So this 4 1 1, there's a 1 island, and again there is a 0. So it's a disconnected here. So but this 4 1 is 1 island, and here there's a 1 1. So this is not connected with this. So this is another island, and if you see 1 1, this is another island. So there are 3 islands here, 1 2 and 3. 0 is a water. So that's a problem, and we have to find out the count of these islands. So how to solve? It's a BFS search. What we do, first we'll traverse each row, each column. We traverse each row and each column. Like let's say we come to 1, and in this place 0 0 position, and we check if there is an island here or not. If there is an island, then we can increase the count, and then we do the BFS, and we write a function which go to the right direction, all right direction. It will go to the left direction, bottom direction, and up direction, and check if there is a 1 here. So if it finds, or yeah, it will just check, go this direction and check if all 1s and make it 0. So this will turn to 0. So till here all turns to 0, and this one down here also, this all turns to 0. So if it turns to 0, next time we move our pointer to this place, and this is already a 0. So in that case counter won't be increased. The first time counter increase, there is a 1 island, and then we made all 0. So if it come here, it's a 0, it comes here 0, comes here 0, and everywhere it goes it's a 0. So in that case the counter will be 1, and then we'll get the output 1. In the same scenario, we can try here. We can start from this position and from 0 0, and we'll see this 1. so we can increase the counter 1, and then we'll make it 0 down also, all the way down till here. If you find 0, stop. So make it 0, this 0 and this 0, and stop. So all becomes 0. Then we'll traverse, come to this place, come to this place, and we'll check all this 0, all this 0, and we know, remember the counter is 1, so it come here, it's all 0, again it's 0. But we, as soon as we come this place, we have not made it 0 because this is not a connected. We go to the right direction, left direction, top, bottom direction, but not the diagonal. So in this case, this is another island. So as soon as we find 1, again we increase the counter 2, and then we'll try to go to the right side, top, left, bottom, and see is there any connected 1, and there's no 1, so that's fine, we'll come out. As soon as you find the 0, we just come out and we count. So the counter is 2. Again we'll come to this place, this, and then come to this place, and then counter, this time counter will increase the counter, so counter will be 3, and we'll make it 0. So this logic we are going to write. This is a very simple. So let's see here. So first we count this, the row, number of row, so it's row length, and then we can say grade, length of grade, and then column length, so length of, say, grade 0, that will be column length, and then we'll traverse each row and each column. So it's we know the normal traversal, I is equal to 0, I less than row length, I plus plus, for j equal to 0, j less than column length, j plus plus, and we need a one counter here, so let's say counter is equal to 0, and we'll compare. Say if it's a grid I and j is equal to 0, then counter plus plus, we increase the counter, and then turn 1 to 0, 1 to 0, turn 1 to 0. So just come here, counter plus plus, and then turn this, all this 1 to 0, all this. So we write that function here. So all this the BFS search. So here we are going to pass grid, and then I comma j, and then it's a row length and column length, row length, column length, and the for loop close here. At the end we can return this counter. Okay, let's see this function. So let's define this function, and it's a grid, type is byte, and then okay, so when we compare this, we should compare like this, 0 within the single quote, and it's ij, so I j row length, column length, all the type are same. So at the end I can say int, and I said, like, when you come here, we are in this position, and then we make it we make a counter, like we increase the counter and then turn it to 0, and then all the right side, left side, bottom, and all connected 1 to 0. So I'll come here and grid I and j, I will turn to 0. Okay, and then I turn this value to 0. Now I want to go to this place, and left side, top, bottom, so I can call this function. So grid, so I want to go to right side, that means column, so I will be same, and j plus 1, I can pass the same row length and column length, and I can copy this 4 times. Okay, so this is first, the first it will go to the right side, and the second it will go to the left side, j minus 1. Then another one, we can, for the row, go to the top, so that is I minus 1, and fix the j here, and then I plus 1. So in this way, from we turn this to 0, and we went to the right side and then left side. So this is j plus 1 right side, j minus 1 go to the left side, and then I minus 1 sub top, and the I plus 1, because I will increase here, so it will go to the bottom. So in this way we did the BFS, and it will turn all 1 to 0. There is in the conditions we need to get out of here. So the condition will be, you see, we are increasing j and decreasing j here, decreasing I and increasing I. So sometimes the j value will goes out of the boundary. It's a minus, less than 0, or it's a greater than length, or I can go out of the boundary, it's a less than 0, or maybe greater than 0. So that condition we need to check, and if that situation comes, we just come out. Also we can check, when we start making this or turning this 1 to 0, then we'll come here, and as soon as we find the 0, then just come out, because that is the stop condition here. So those conditions we need to check this place. So let's say if I less than 0, or I greater than equal to, it's a row lane, or j less than 0, or j greater than equal to column lane, or grade ij, so grade ij equal to 0, then just return. So that's the logic here, and we'll get the exact count of this island. So let's run and see for the syntax error. So I less than, what is the row lane? Okay, so here one thing is like this one also, and I greater than row lane, j less than 0, j greater than equal to column lane. I think it will be good now. What is there? I less untyped bool value not use greater than row lane. So I checked ij, that's int, I less than 0, I greater than row lane. Oh, okay, this or need or here. Yeah, let's try again. Why it is wrong answer? Grade I, j plus 1, j minus 1, and then we fix j, I minus 1, I plus 1. So this is good, and then we make it 0 here, that's also good. As soon as we find 0, come out, less than 0, this is also good, and j less than 0, j greater than equal to column lane, this seems good. Another one this side, grid ij, oh here, so grid ij equal to 1. So in this time just we want to see 1. So yeah, that's a thing. Okay, let's try now. Okay, accepted. Submit this. it's good, it's accepted. Let's see Java solution. So Java solution, same logic, row lane and column lane and count 0. We are traversing here each cell, and then comparing grid ij 1 counter plus plus, and then turn 1 to 0. This is the exit condition. If it goes outside of the boundary, then just return, otherwise turn to 0, turn 1 to 0, and then we're going to the all directions here. So that's all for today. Thank you.